We'll explore what prime numbers are, how they form the building blocks of all integers, and how we can use prime factorization to break down any number into its prime components. Let's start with understanding what prime numbers are. A prime number is a natural number greater than one that cannot be formed by multiplying two smaller natural numbers. In other words, a prime number has exactly two factors, 1 and itself. For example, numbers like 2, 3, 5, 7, 11, and 13 are all prime numbers. Let's look at the number 7. The only factors of 7 are 1 and 7. We cannot find any other natural numbers that multiply together to give us 7. On the other hand, numbers like 4, 6, 8, 9, and 10 are not prime numbers because they can be formed by multiplying smaller natural numbers. Let's look at the number 6. The factors of 6 are 1, 2, 3, and 6. We can express 6 as 2 times 3, so it's not a prime number. Now, let's talk about prime factorization. Prime factorization is the process of breaking down a composite number into a product of prime numbers. Every integer greater than 1 can be expressed as a unique product of prime numbers. This is known as the fundamental theorem of arithmetic. Let's look at an example of prime factorization. Let's take the number 84 and break it down into its prime factors. First, we divide 84 by 2, which gives us 42. Next, we divide 42 by 2, which gives us 21. Then, we divide 21 by 3, which gives us 7. Finally, we divide 7 by 7, which gives us 1. Since we've reached 1, we're done. So the prime factorization of 84 is 2 times 2 times 3 times 7, or 2 squared times 3 times 7. Another way to find the prime factorization is using a factor tree. We start with our number 84 and find any two factors that multiply to give 84. Let's use 2 and 42. Now, we check if each of these factors is prime. 2 is prime, but 42 is not, so we further factorize 42 into 2 times 21. 2 is prime, but 21 is not, so we factorize 21 into 3 times 7. Both 3 and 7 are prime, so we're done. The prime factorization is 2 times 2 times 3 times 7. Prime factorization has many applications. It helps us find the greatest common divisor, or GCD, and the least common multiple, or LCM, of two or more numbers. It's also fundamental in cryptography, especially in RSA encryption, which relies on the difficulty of factoring very large numbers into their prime components. To summarize, prime numbers are the building blocks of all integers, and prime factorization allows us to express any number as a product of these building blocks. Thank you for watching this lesson on prime numbers and factorization. I hope you